These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. By the way, I also offer tutoring via Skype, and you can find more information about that Skype tutoring service at my website.
In particular, part B, where I wanted to know if for the first SN2 reaction, if you could still use, or why you had to use KBr with DMSO, and if you could use KBr with any aprotic solvent.
Is that the only question, or did you want to go
Yeah.
through the whole thing?
No, that was my only question.
Oh, okay. Yeah, so when you're doing a synthesis problem, you can get it correct if you use any reagents that will work. But in many cases, there's more than one reagent that will work. And in particular, there's almost always more than one solvent that will work. So yeah, you can't, you don't need to use the same solvent as they're using in the problem. You should try to make sure that, unfortunately, that makes it difficult to tell whether you're getting it right though.
Right.
Because it makes it difficult to tell whether you're using the correct solvent. It might be safest maybe to check with me or your TA on those things. But generally, for example, if they're using an aprotic solvent, you would be best off using an aprotic solvent. And if they're using a protic solvent, you would be best off using a protic solvent as well.
Okay.
Was that all you wanted to talk about?
Yeah.
That one? Okay.
And then,
That's fine.
you want to do more synthesis like on the practice exam? Or on
What did we do yesterday that
in the review?
yeah. Like the Grignard reactions
Mm-hmm.
and how we use those in whatever the heck we use them.
Oh, because Grignards are the only way to supply or to add on carbons. If you're going from like a 4-carbon molecule to a 7-carbon,
Mm-hmm.
Grignards is the only way to add carbons.
Can we just do like one problem like that though? 'Cause I
Yeah.
don't know.
Yeah.
So, Grignard problem?
Yeah.
Okay.
Is there any way we can start with an alkane and that where we have to generate our own Grignard?
Yeah, we can do that.
Okay, afterwards?
Yeah, sure. So it's important to know, I was going to start with what do you do with Grignards, but you also need to know how to make Grignards as well. So yeah, Grignards are one of the most important reagents in the class, so it's important to be familiar with those. Okay, so first of all, this is what we call a Grignard reagent. So what is a Grignard reagent? Well, the general formula for a Grignard reagent So here are the 3 kinds of Grignard reagents. So it's basically, remember that R just stands for a carbon chain. R just stands for a carbon chain here. So we have a carbon chain bonded to a magnesium, and then the magnesium should be bounded to a halogen. But I don't think you can make Grignards with fluorine, so you would use chlorine, bromine, or iodine. So this is what we mean by Grignard reagent. Okay, so this is Grignard. All right, well, why don't you guys try working out on your paper. Let's go through what would be the mechanism. Oh, so actually, to tell you the truth, I really didn't write this the best way. I should have written. So let's try going through the mechanism here. So first we're going to add this reagent, and then we'll add the H3O+. So you guys know that when we number the steps, that means these are separate steps. This reagent is added separately from this one. Okay, so let me look over your shoulder and see if we can get this mechanism right. If you got a pencil, that would be the best thing to use.
I don't even know.
Okay?
I haven't gone with it. No.
Yes, that would be a good thing for us to focus on today. This is a big, important idea. Okay. So let's both go through this, let's all go through this together then. So yeah, it looks like we should go over the basics here first. So why don't we take a step back from this reaction and go over the basics for a Grignard reagent. I'm going to erase this actually. Okay, now what type of bond would we expect to have between this carbon and this magnesium? Covalent or ionic?
Which two?
Between this carbon and this magnesium, what type of bond would we expect between them?
Covalent.
Covalent. Why would you say that?
Because carbon is not a, like when it
Just big ionic bonds.
an ion.
Okay, so let's go through how we decide. Generally speaking, so would you say that carbon and magnesium are from the same side of the periodic table or opposite sides? You guys know where magnesium is in the periodic table? Yeah, magnesium is on the left. That is, it's on the metal side. Well, is carbon on the left or is it on the right?
Right.
It's on the right. So these are on different sides of the periodic table. Carbon and magnesium are on different sides of the periodic table. Does that mean they have the same appetite for electrons or different appetites?
Different.
Yeah, very different. Well, when things have very different appetites for electrons, do they tend to make ionic or covalent bonds?
Oh, ion.
Ionic, because remember, ionic means we're transferring the electrons. Okay, so another way to put it is this is a nonmetal and this is a metal. That's just another way of saying that this is from the right side of the periodic table and this is from the left side of the periodic table. So we would expect here to form an ionic bond. Okay, now the first thing, now actually, unfortunately that rule is not hard and fast. Even though magnesium is a metal, it's kind of on the right side of the metals. Magnesium is actually, if you look at the periodic table, not that far from carbon. It's on the right side of the metals. So it turns out that technically speaking, it's probably most accurate still to think of this as a covalent bond. That's why I drew it as a straight line over here. I drew it as a straight line. Remember that when we draw bonds like this, we mean they're covalent. This is how we draw a covalent bond. So technically, this is probably closest to being covalent. However, it's very close to ionic, right? We've seen that it's very close to ionic because we do have a metal and a nonmetal. And it turns out that for solving problems, it's much easier to solve problems if you treat this bond as ionic. And that should generally be acceptable to your instructors. In fact, a lot of instructors recommend that you do that. So we're going to treat the Grignard reagent as if it was ionically bonded. But you have to keep in mind that oftentimes you'll see it drawn as covalent because maybe scientifically maybe this is a little bit more accurate, but for solving problems it's much easier to think of it as ionic. It's pretty close to ionic anyway, as we would expect, because we have a metal and a nonmetal. All right, so now let's very carefully turn this into an ionic bond. Let's rewrite this as an ionic bond. Well, I'll show you the right way to do it, and then I'll warn you against the wrong way. So the right thing to do is first erase the covalent bond. First, erase the covalent bond. So I've done that. I've erased the covalent bond. And second, put in the charges. Remember, the way you show an ionic bond is by putting positive and negative charges in. Well, who should have the negative charge here? The carbon or the magnesium? Carbon. That should be plain because the carbon is further to the right in the periodic table. It wants the electrons more. The carbon wants the electrons more. So the magnesium would have the positive charge. So remember, this is the way we show an ionic bond. In a sense, you don't really draw ionic bonds, you just imply them when you put a negative charge close to a positive charge. Ionic bonds aren't really drawn, but they're implied when you have something with a positive charge close to a negative charge. So this is the correct way to redraw a Grignard. So anytime you see a Grignard with a covalent, the very first thing you should do is redraw it as ionic. You want to get in the habit of doing that every time. Okay, now let me show you the common mistake that people tend to make here. Remember, the right method is erase the covalent bond and then put in the charges. So here's where people could go wrong. A lot of people skip the first step. A lot of people don't start by erasing the covalent bond. Well, if you don't start by erasing the covalent bond, it's tempting to do this. Remember, this is the wrong way. It's tempting to do this. This is wrong. Can you see what's wrong here? Well, I just invented a new carbon, right? There isn't really a carbon over here, but this is a really common mistake, so you really have to watch out for this. There is no carbon here. Now I've made this into a 4-carbon chain when we really started with the 3-carbon chain. Well, the best way to make sure you never make this mistake is to always start by erasing the covalent bond first. You're gonna have to do that anyway, right? You can't draw both an ionic and a covalent bond between the same 2 molecules. That's not done. And then it would be ridiculous to put a negative charge here, right? So if you started by erasing the covalent bond, you couldn't make that mistake. All right, so again, the correct method is first, erase the covalent bond, then put in the charges.